little drop of water, a tiny drop. And the atoms attract each other. They like to be next to each other. They want as many partners as they can get. Now, the guys that are at the surface have only partners on one side here, in the air on the other side, so they're trying to get in. And you can imagine this team of people, these teeming people, all moving very fast, all trying to have as many partners as possible. And the guys at the edge are very unhappy and nervous, and they keep pounding in, trying to get in, and that makes it a tight ball instead of a flat. And that's what, surface tension, the way when you realize, when you see how sometimes a water drop sits like this on a table, then you start to imagine why it sits like that, because everybody's trying to get into the water. And at the same time, while all this is happening, there are these atoms that are leaving the surface, and the water drop is slowly disappearing. Rolling over each other. They're in a nice pattern, like oranges in a crate, in a nice organized pattern, all just jiggling in place, but not having enough motion to get loose of their own place and to break the structure down. And that's what I'm describing as a solid. It's ice. It has a structure. If you held the atoms at one end in a certain position, all the rest are lined up in a position sticking out, and it's solid at the end. Whereas if you heat that harder, then they begin to get loose and roll all over each other, and that's the liquid. And if you heat that still harder, and they bounce harder, then they simply bounce apart from each other, and they're just individual, I say atoms, there's really little groups of atoms, molecules, which come flying and hit. And although they have a tendency to stick, they're moving too fast. Their hands don't grab, so to speak, as they pass, and they fly apart again. And this is the gas we call steam. A little